Yes, we are back with another FRQ. We are at FRQ 3 of AP Calculus BC 2025 exam. As before, you will get a clear step-by-step explanation for this question. And most important thing is it is non-calculator paper. So we're going to solve the question completely without calculator assistance. So yes, for this you need many strategies, many skills, like math skills you need to solve this without calculator. And yes, today I'm going to clarify this for you. And we are into FRQ 3. Let's dive into this without any delay. Here we see. A student starts reading a book at a time t equal to 0 minutes and continues reading for the next 10 minutes. The rate at which the student reads is modeled by the differentiable function r, where r of t is measured in words per minute. Selected values of r of t is given in the table. For t minutes, how much words per minute is had been read. So 0, 90 times 2 minutes, it's 100, something like this. We have four subdivision. For the first one, we need to approximate r prime 1 using average rate change concept. And we need to show our work, indicate units of measure. Even though it's not mentioned, always show the work and unit of measure, just mention that. So B, must there be a value C such that R of C is 155? We need to justify our answer for this case and then use a trapezoidal sum to approximate the value of a given integral. We need to show our work. And then a teacher also starts reading at time t equal to 0 minutes. A teacher is also reading. A student case was given mainly. Now the new case is teacher and continues reading for the next 10 minutes, a complete different function. The rate at which the teacher reads is modeled by the function w of t. And it is also measured in words per minute. Based on the model, how many words has the teacher read by the end of the 10 minutes? Show the work that leads to your answer. Only difference is for the rate, table is given. Here, function is given. Right? So let's see how to solve this and get a very solid understanding on these concepts. And these are repetitive concepts that we can find in every AP exam, like working on the table values and working how to work when a function is given to you. And the trapezoidal sum, many things are repetitive. So be ready and solve along with me. Here we go for the first part. Approximate r prime 1 using the average rate of change of r over the interval. R prime is rate of change, but it's instantaneous, right? But instantaneous with the help of average rate of change. Over the interval 0 to 2, of course, 1 lies between 0 and 2. You can think 0 and 8 also, but this is the best average. This will give you the better estimate. So we are doing it. So it's nothing but average rate of change is slope formula. So r prime of 1 is r of 2 minus r of 0 divided by 2 minus 0. That's it. So which is r of 2 is 100, r of 0 is 90 over 2, which is 10. Okay. R is words per minute. R prime is words per minute per minute. So this is 10 over 2 actually. Sorry, it's 5. So R prime of 1 is 5 words per minute per minute. Okay, so actually you can represent this per minute square. That is also fine. So this unit is important. The given function itself, it's per minute. So 1 word per minute you need to give, right? Or if you just confuse with minute squared, how this comes. So words per minute, again use a per minute. Because this is the R of, okay, how this comes up, let me explain. So the numerator unit is what? Words per minute. Denominator is time, it is also per minute. That's why it's words per minute, and if you simplify, it's per minute square. Okay, so that's how you have to interpret the exact unit. That simple A part is, we are moving to B. Okay, here we have a question and we need to give justification. Must there be a value C for 0 to 10 such that R of C is 155? Justify your answer. Okay, so from 0 to 10, do we have any value of C such that, for example, will any value of like 3 is 155 or 3.1 is 155, something they're asking, some value, will I get an output 155? Okay, how can I check this? If you clearly see this is intermediate value theorem, IVT. Okay, so do we have any value in between the given intervals of time. That is what we're going to check. So intermediate value theorem, what are the conditions to apply? I can't apply it for everything. So it should be differentiable. It should be continuous. If it's continuous, I can apply this. So let's see the description again. R of t is okay, table of values given, and they clearly mention it's a differentiable function. Okay, I have this information. R of t is differentiable. Differentiable, right? On 0, 10. So 0 to 10, it's differentiable. So if it's differentiable, for sure, it must be continuous. So R of t is continuous and IVT is applicable. Continuous on 0, 10, right? So R of 8 is 150. Why I'm taking R of 8 suddenly? I'm looking for, is there any value between 0 and 10? So that I can clearly see 90 to 100, 150. So here is where your 150 lies between. So I'm picking this particular interval. Okay, not 0 to 10. So R of 8 is 150 and R of 10 is 162, right? And maybe I'm not telling R of 9 is 155. Many infinite values are between 8 and 10, correct? So 155 falls between 150 and 162, which is R of 8 and R of 0. Sorry, I mean R of 10. So what it's a continuous thing, right? So 150 to 162, the graph is extending. Of course, it will cross 155 somewhere, right? If it goes, it's a continuous means there's no break. Of course, it should give the output 155. For example, let me explain. So 8 to 10. For 8, I'm reaching 150. Then 10, I'm going to 162 somewhere here. Okay. So it's continuous means I should cross some value must give the value 155. Correct? Without crossing 155, can you go to 162? No, right? So this is what IVT help us. So that's simple. You have to mention this by IVT. There must be a C. In 8, 10, such that, so I'm very peculiar now. It's between 0 and 10, they ask us to check, but I'm sure it's between 8 and 10. Such that R of C is 155. Yes, it is possible. So you can give a big yes for this. Yes, it is possible. That must be a C. Right. Moving to part C. Use trapezoidal sum with the 3 subintervals indicated by the data in the table to approximate the value of 0 to 10 R of t dt. Show the works that leads to your answer. Okay, area under the curve using trapezoidal sum. Quick review on trapezoidal sum. How will you find the sum? 0 to 10 if your curve is there. 0 you take, and in, like, for example, we are dividing it to 2, 8 and 10. Okay, 0 to 10, and you make a trapezoid instead of rectangle. And then trapezoid, for each interval, you should find the area of the trapezoid. Okay, like this you can do, or you can do like this. Okay, make a trapezoid. And for 10, for example, 10 is here, you make a trapezoid like this. Right? And we are finding the area. Right? So let's do it now. Okay, this is just a reminder. So if your trapezoid is something like this, parallel sides is A and B, and the distance between them is this. So half into sum of parallel sides A plus B into the distance between them. Okay, this is the actual formula. So let's work on intervals and width. Intervals and width. This is important. So in the interval 0, 2, the width is 2. For the interval 2, 8, how I'm finding width? Just subtract it. 8 minus 2, 6. For the interval 8, 10, the width is 10 minus 8 is 2. Okay, so let's find the area now. Coming to area one. Area for each interval. So 0 to 2. This is R of A and R of B. That is the actual value of this one. Okay, so half into A means like it's not 0. So if you, which is 90 here. Okay, so 90 plus R of 2 is 100. So that output we need because it's the height. If you're at 0, it's 90. So this is 90. If you're at 2, it's 100. So it's 100. Okay, that's important. Half into 90 plus 100 times the interval with this 2. Simplify 2 will get cancelled. 90 and 100 is 190. We're going to repeat it for every interval. 2, 8. Half times R of 2 plus R of 8. So just add it up. 100 plus 150 times it's 6. So simplify 1 times is 3 and 250 times 3 is 750. Right? And 8 of in the next interval, 8 comma 10. Same. Half R of 8 is 150 and 162. Times with this 2 will get cancelled. Just add it up. 312. And you add up everything, which is 2, 5, and 12. So 1 to 5 is what I got. Okay. So now using trapezoidal rule, we have solved 0 to 10 R of t dt is 1 to 5 to approximation only. Okay. So what does it mean? R of t, it's word per minute. Right? And the differentiation of this is just the words. So 1 to 5 to words. Okay. If you are reading this much rate, sum of all this, it will give you the words. So make sure the unit is just words. So now approximately 1 to 5 to words. Right. Moving to the final part of this. A teacher also starts reading at time t equal to 0 minutes and continues reading for the next 10 minutes. The rate at which the teacher reads is modeled by the function W defined by this. W of t is measured in words per minute. Based on the model, how many words does the teacher read? We need to find the words. So you just integrate the rate function. Okay, and differentiation of this. So from 0 to 10 minutes, how much the teacher reads? So W of t, the rate function, accumulation of change. Correct? W of t dt. So 0 to 10, W of t is clearly given, minus 3 by 10 t square plus 80 plus 100, use a bracket and put dt. We need to do it without calculator, right? So minus 3 by 10 is a constant. T square, when you integrate, it's t power 3 by 3. Okay, sometimes we will mess up with differentiation and integration formula. You might do 2t. So make sure, think twice and apply it. Then 8. T, when you integrate, it's t square by 2. Then 100, when you integrate, 100t. And 0 to 10. Now we need to plug in the values and simplify this. So negative 3 by 10. And I'm going to apply the upper limit, 10 cubed by 3. Plus 8 into 10 square by 2. Plus 100 into 10. And when you apply 0, here everything 0 times anything is 0, here 0. So everything will get nullified. So which is 0, 1. So lower limit, when you apply, it's 0. So minus 0 means nothing. So that's it. And cancel this 3 cancel. 10 cubed by 10 is minus 100. 1000 by 10. And here 1 times 2, 4 times. 4 times 100. 10 square is 100. So it's 400. 10 times 100, it's 1000. So 1400 minus 100, it's 1300. Simple addition works. This is exact, right? Not an approximate one. So 1300 words the teacher is read by the end of 10 minutes. Right? That's simple. So with this, we come to the conclusion. I hope this discussion might be helpful to you. If yes, you can share it with your friends. And to show your love, you can like, subscribe, and also do watch the other playlist. And if you want to join the Let's Unbound student community WhatsApp group, you can click on the link which is given in the description below. Thank you for watching. Keep learning and keep practicing. We will back with next FRQ very soon.